An element with atomic number 1. An element which doesn't have a fixed position in the periodic table. An element which is the smallest element in the periodic table. When it combines with its own self, it forms H2, that we commonly known as hydrogen gas. Well, what is this hydrogen, green hydrogen, other different colors of hydrogen? A lot more waiting for you in today's session. This is me, Nitika Dugal, and I welcome you to Universal Group of Institutions. I hope you have already subscribed to the channel. Here we bring you amazing content based on different questions that can be asked in UPSC KAS mains examination. Also, we at Universal Group of Institutions offer you degree courses and we also make you job ready. Do check out the description below to avail a seat. You can also use my referral code NIT006. Now with this, let's dive into the topic. We are here to learn about green hydrogen in India's energy transition. This is one of the very promising sources of energy. Let's ponder on what is exactly green hydrogen. So green hydrogen is the hydrogen produced using renewable energy like solar, wind, hydro through electrolysis, making it a zero carbon fuel. You heard it right. There is no carbon as a byproduct which is formed in this whole process, in this whole reaction of combustion here. Combustion in general, what is the definition? For example, there is any particular compound which is containing carbon, then it will produce carbon dioxide, and most of the fuels contain carbon. Here, the reaction is not with actually carbon. Carbon is not in the scene. What we have is H2 plus O2 giving us H2O. Just the opposite of it now. H2O giving us H2 plus O2. Now this can happen via electrolysis. We'll learn about electrolysis also a bit. Now here, why is a colorless gas given so many colorful names? Now let me tell you, it's not just the green hydrogen term that you shall be hearing from me. There are many different colors. So like they say, tippy tippy tap, what color you want. You can actually name a color and we may just check. Okay, pink, yeah, pink hydrogen we do have. Similarly, if I talk about turquoise, blue, gray hydrogen, yes, all of these we do have. We'll also try to figure out what's the difference between different types of hydrogen. So green hydrogen, blue hydrogen, brown hydrogen, and even yellow hydrogen. So many colorful names. Now, yeah, turquoise hydrogen and pink hydrogen. Literally every color is here. They are essentially color codes or nicknames used within the energy industry to differentiate between the different types of hydrogen. Now, what are these types of hydrogen? We need to get on that now. So here we have, what does hydrogen look like actually? Hydrogen itself is a colorless gas. It doesn't have any color. So like it is rightly said that these are just to differentiate different types of hydrogen, and we need to now know what are these different types of hydrogen, correct? Now, hydrogen is an invisible gas, colorless gas. So despite their colorful description, so many names that you've just heard, there is no visible difference between different types of hydrogen. And here is the green hydrogen coming our way. Green hydrogen is made by using clean electricity from surplus renewable energy sources such as solar, wind power to electrolyze water. So we are making use of the renewable energy resources to carry out the process of electrolysis. Okay, so electrolyzers use an electrochemical reaction to split water into its components of hydrogen and oxygen, emitting zero carbon dioxide in the process. So it's also a combustion reaction. Reaction happening with oxygen to give the highest oxidized product is what is actually combustion. Because in the process here, what generally happens, let's say methane. I'll give you the formula how the combustion reaction looks like. So if I talk about actually methane, CH4, it can react with oxygen, right? So methane, do we know that? Where do we actually find methane? Yeah, it is the CNG, compressed natural gas. So this is CNG I'm talking about right now. Something that we are using in autos, in vehicles, right? Okay, so the combustion reaction looks like this. CH4 plus O2 gives you CO2, right? And H2O. Now here again, it's just that the fuel we are changing from a carbon hydrogen compound to H2. It would react with the oxygen because combustion cannot happen without oxygen. So this is the kind of the reaction which is happening, which actually H2 plus O2 should give you H2. This is the reaction which we actually know that happens. But through electrolysis, we can just do opposite of this. H2O can be split. This molecule, H2O, can be split to its components. It is made up of the two components, which are two elements, H2 and O2. So yes, that's what we get. Now, where are we using the energy for this electrolysis? Through the renewable energy sources. So that's a great piece of information for us about green hydrogen. Now let's talk about blue hydrogen. So blue hydrogen and other forms of hydrogen are not of much interest to us. So we will just bypass them a bit. What is very, very important from our examination point of view is the green hydrogen precisely, right? But let's just find out the difference, we are very inquisitive to know what are the different types of hydrogen and why are we giving such colorful names? I mean, how are they different? If all of them are transparent, all of them are colorless, then what's the difference? Let's find out. Blue hydrogen is produced mainly from natural gas using a process called steam reforming, which brings together natural gas and heated water in the form of steam. The output is hydrogen, but carbon dioxide is also produced as a byproduct. So the definition of blue hydrogen includes the use of carbon capture and storage to trap and store this carbon. So you can understand here we are not just getting, there's no carbon dioxide. We can't eliminate that there's no carbon dioxide. There is some carbon dioxide. So this is when we are starting with the source is the CNG, again, the methane, CH4, the hydrocarbon, the smallest hydrocarbon that we're using here. Now, mind you, green hydrogen will, like we just read the definition, there is no byproduct named carbon dioxide whatsoever. Okay, so now we have, let's say, gray hydrogen, which currently this is the most common form of hydrogen production. Gray hydrogen is created from natural gas or methane using steam methane reformation, but without capturing the greenhouse gases made in the process. Gray hydrogen is essentially the same as blue hydrogen, but without the use of carbon capture and storage. So pretty much we understood, okay, it's very much similar to what we learned about blue hydrogen. It's just that we're not doing any kind of carbon capture here. That's it. And next is now our black and brown hydrogen using black coal or lignite, which is brown coal, in the hydrogen making process. These black and brown hydrogen are the absolute opposite of green hydrogen in the hydrogen spectrum and the most environmentally damaging. So the whole purpose is to produce something which is environmental friendly and which can cater to the needs. So that's why we are calling it energy transition, a great source of energy transition that can happen. So yeah, here now we have other forms of the hydrogen as well. If we see, the first one is pink hydrogen, which is generated through electrolysis powered by the nuclear energy. So that's how precise the definitions are. Here we're using, let's say, methane. In another one, we're making use of the carbon coming from the coal or lignite. In one, we are using the nuclear energy. We're not making use of, like in green hydrogen, we were making use of the renewable energy sources like solar, like wind, like hydro, right? Okay, now nuclear produced hydrogen can also be referred to as purple hydrogen or red hydrogen. More names, more colored names coming our way, right? Colorful names coming our way. I told you, tippy tap, what color you want. I want turquoise. We have the turquoise hydrogen as well. We can just tally it from our game. So this is a new entry in the hydrogen color charts, and production has yet to be proven at scale. Turquoise hydrogen is made using the process called methane pyrolysis. So I'll tell you what pyrolysis is. It is lysis with the help of pyro. Pyro is what? Heat. So you're making use of heat to break. Lysis means breaking. To break, you're making use of the heat. So you're making use of the heat to break methane to produce hydrogen gas, okay, or produce hydrogen and solid carbon. Next one is yellow hydrogen. Yellow hydrogen is a relatively new phrase for hydrogen made through electrolysis using solar power. So solar power also coming our way, specifically solar power. We're calling it yellow hydrogen, maybe from the sun. So there is a certain relevance of the color as well if you observe out here. Okay, now if you see the next one, white hydrogen is a naturally occurring geological hydrogen found in underground deposits and created through fracking. Okay, now what is this fracking? Fracking is nothing but, with high pressure, you inject maybe from a borehole or from subterranean regions, you are going to inject the water at such high pressure that if there are any fissures or any such trapped gases, they would come out. And we know about the shale boom that happened in US. That's through the process of fracking. Okay, so this is white hydrogen now that we are talking about, the one which is trapped underground. All right, now here we have what is green hydrogen and how is it obtained. So this is what we should know exactly what it is. This technology is based on the generation of hydrogen, a universal light and highly reactive fuel, through a chemical process known as electrolysis. This method uses an electrical current to separate. So we'll just decode what electrolysis is. It is lysis with the help of electricity. Just like how we learned about pyrolysis, that lysis with the help of heat. Here we can think of electrolysis as lysis with the help of electricity. So I'll just tell you more about electrolysis. First, let's read what we have out here and then we will get into some depth of electrolysis as well. Okay, so this method uses an electrical current to separate the hydrogen from the oxygen in water. If this electricity is obtained from renewable sources, we will therefore produce energy without emitting carbon dioxide in the atmosphere. Like we saw the reaction H2O giving us H2 plus O2. There's no carbon dioxide in the reaction. So as the IEA points out, this method of obtaining green hydrogen would save the 830 million tons of carbon dioxide that is emitted annually when this gas is produced using fossil fuels. Likewise, replacing all grey hydrogen in the world would require 3000 terawatt hour per year. So terawatt hour, we know watt is the unit of power. So we are talking about units of electricity here. So it is 1 trillion watt hour per year. That is how huge. So 3000 trillion watt hour per year from new renewables, equivalent to energy demand of Europe. Now that's huge. You can understand Europe is a huge continent in itself, isn't it? So yeah, however, there are some questions about the viability of green hydrogen because of its high production cost. So here we are able to understand the challenges also, right? So reasonable doubts that will disappear as the decarbonization of the earth progresses and consequently the generation of renewable energy becomes cheaper. So here we have the International Energy Agency's point of view. So International Energy Agency has actually mentioned how important can green hydrogen be and the challenges related to it. Now we'll dive a bit into this whole process that we are referring to as electrolysis. Now generally what happens is if there is a spontaneous reaction like H2 plus O2 will itself form H2. You don't have to intervene. This is happening in nature on its own. It is a spontaneous process. What do you want to carry out? A non-spontaneous process, which is from H2O you want H2 and O2. Now this would require some energy. Where are we providing that energy from? We are providing it from the process of electrolysis. So you can see that here we have on the cathode side the emission of hydrogen and on the anode side the emission of oxygen. So this is with the help of the electricity that we are carrying out this non-spontaneous reaction and producing hydrogen from this whole process of making use of the electricity. Now, what is the need for the green hydrogen? Why are we so much talking about it? We have understood the context that it is certainly a very cleaner source of energy. Hydrogen gas is not very problematic for us as compared to carbon dioxide gas, which is a greenhouse gas, which is causing global warming. And we know the rise in the temperature, how it is leading to the glaciers melting, the floods coming, the sea levels rising, which is leading to the dislocation of people, all of that. So here we have what is the need of the green hydrogen. So dependence on coal and oil imports is a lot that can be reduced if we know how to make use of this whole process of electrolysis, which can be very convenient if more people starts to use this form of energy. Like for example, solar panels were a little expensive one point in time. Now that the people have started installing the solar panels at their homes, there are subsidies, right? So just like that, it can be tackled. Now, rising energy demand with climate change commitments. So yes, we have to be aware of the environment. We have to consider the climate change. We have to be empathetic towards it. We have to be serious about it, right? Okay. Now, major green hydrogen projects in India. Let's just very quickly talk about all of them. There is one in Andhra Pradesh. There is this Reliance Industries Dhirubhai Ambani Green Energy Giga Complex. There is Adani Group's Green Hydrogen Initiatives. There is this ACME Group's Larsen and Turbo's L&T Electrolyzer Manufacturing, Jindal Stainless Steel's Green Hydrogen Plant, SGVN's Multipurpose Green Hydrogen Pilot Project, Plug Power's planned hydrogen production plants. Let's talk about each one of them one by one. So the first one, NTPC. Do you know that NTPC is producing $21 billion green hydrogen hub in Andhra Pradesh? $1 billion. Okay. Now, the next one, Reliance Industries Dhirubhai Ambani's Green Energy Giga Complex. They have committed 10 billion investment in this field of green hydrogen. Then Adani Group's Green Hydrogen Initiative. So Adani Group has also committed a huge investment in this green hydrogen economy. L&T Electrolyzer Manufacturing, they've recently commissioned one electrolyzer with a whopping capacity of 1 megawatts. And this has happened recently in 2024. Then these are the other projects that we have. SJVN, which was formerly known as Satluj Jan Vidyut Nigam. So now we know this PSU as SJVN. Then Plug Power's planned hydrogen production plant. So these are some plants that we should know. Then advantages of green hydrogen are, of course, that it is zero emissions, supporting India's net zero goals. The energy security that we get from here, reducing oil and gas imports, job creation in hydrogen production, storage and transport, industrial applications in hard to abate sectors. So there are quite many advantages. The governments are also in favor of the hydrogen economy. Of course, it is a big step towards the climate change as well. But of course, it comes with its own challenges. Challenges being that it has a high cost. This electrolysis process that we were talking about is expensive compared to simply the fossil fuel based hydrogen. Infrastructure gap, the storage and transportation requires specialized pipelines and fuel cells. Renewable energy dependence needs massive solar wind power expansion. Efficiency loss, hydrogen conversion and transport reduces the net energy efficiency. So there are quite many challenges as well. But yes, the work is going on in the field. And this is one of the very promising sectors, a very promising energy fuel. This element with the atomic number 1, we need to yet observe that will it become our number 1 fuel in future. With this is me, Nitika, signing off. See you in another video with more amazing concepts and questions that can be asked in your examination.